Well, Havok's been around for about 7 years now. It started out in Ireland, in Dublin, and guys had a dream of bringing real physics into next generation games. And they've achieved that. You know, we've been pretty successful at that with a lot of major titles.
Havok's been a great partner for us. They really bring in the technology that helps us really fine-tune this destruction, being able to really bring the true physics of the environment together, the ragdoll physics, everything that Havok brings to the table really helps the John Woo gun battle and the excitement and the chaos and the mayhem.
Intel enjoys a pretty strong working relationship with Havok on the whole. The enabling work that we do with game developers directly relies on middleware companies such as Havok. So, you know, we've got engineers calling on Havok, working very closely with them to get their tools scaling on our architecture.
We sell our products in different components. So we sell a physics product, a basic animation product, and this is the Havok behavior product. And it's really all about taking it to the next level where artists can actually start crafting these behaviors. In the past, a lot of brilliant artists and developers have worked together, but often the way they exchange ideas is, you know, technically through email or with code. And we're trying to bring a tool to the middle of this that actually fills the gap between the traditional Max, Maya, and XSI tools and code. And so this tool will let artists pull in their animations, much in the way a video compositor might pull in a bunch of video and start working with it and come up with a behavior, in this case, an interactive behavior for a game that can actually go right into the game.
Jeff, enough talking here. Let's go ahead and
all right,
take a look at the Havok behavior. So I know you guys got a demo here for all of us to see, so let's go ahead and check it out.
Sure, yeah. So this is one of our customers' flagship studios let us use one of their characters. This is a guy called Fetid Hulk. And Fetid Hulk is...
sexy.
Yeah, he's very sexy. He's got a lot of personality. Yeah. Well, often when you make character animation, you start out with individual animations that do something. This is what we call an idle state. This is what we call a walk forward state. And actually we can kind of view that on a treadmill, so you can always see what he's doing. Here's a walk backwards state. But it's combining these things all together in a way that is what probably most people are used to when they play a game, that a behavior is all about. This particular state we've got here blends all those things in a more meaningful way, so we can actually have this guy running around, slowing down gradually, going backwards, going around corners, and even at times maybe doing a hit reaction or going into this kind of spit action, because he's the kind of character that likes to spit. Apparently. Yeah. So artists can actually build these things up themselves, and when they're done, give that result over to the programmers, and the programmers can focus on another higher level above and beyond this kind of art.
Now, what other key features does the Havok behavior tool have over other SDKs?
Well, one of the things, I mean, that we have is a hierarchical finite state machine. It's a very technical term for a way to actually group things in branches of motion or behavior that you know, isolate some of the complexity. So you're dealing with something, for example, like, what does a spitting behavior really look like? Well, he starts, he loops, and he finishes. And you can craft that all inside of one window and then move on to another part of the behavior. So this hierarchy of these behaviors really helps the artist kind of zoom in on a particular aspect of the behavior when they're working.